But actually, the stuff that we teach you is not that important. Whatever it is that we teach you doesn't matter so much. Welcome to Frank Stajano Explains. Today's topic is how should you choose what to do at university? An enterprising high school pupil called Rishabh had been watching my channel, and he approached me for advice on how to choose the best university course to support his interests. He did so through the introduction of someone I know quite well. Since they caught me in this period in which I was interviewing lots of computer scientists to offer advice to school pupils, I thought it would be fun to throw into this mix also a video, this video, in which we speak not just to an invisible audience of school pupils, but with an actual school pupil, so that we get to hear their own genuine questions directly, rather than us making up the questions that we think they would ask. So for once, I'll be answering questions rather than serving as an interviewer and asking them. But because the interests of this young gentleman revolved around bioinformatics, of which I know very little, I recruited my good friend Pietro Liò, who is another Cambridge professor, to back me up. Now, some of the things we discuss with Rishabh are very specific to bioinformatics. But if you follow through to the end, you'll find that this video is actually helpful to a much wider audience than you might at first think, because some of the advice we give him throughout the video is valid for everyone who's thinking about the subject they want to do at university, regardless of what the subject actually is. Please stick a like on it if you enjoy this video. I'm very grateful when you do, and it helps the channel very much. And if you have any questions, ask us in the comments. You were introduced to me by your brother, who's my student at Trinity.
Yeah.
You are a bit younger and you still have to choose what to do at university, and you've been doing very well in things to do with biology, and you're considering doing something to do with bioinformatics. And you sent me a number of questions on what to do at university based on having watched my advice on the channel and so on.
Yeah.
You had very specific questions about where does bioinformatics take me, and what can I do? What's the difference between this and that? And while I'm happy to give you general advice about computer science, your questions were so specific that I thought it would be best to have them answered by an expert, and the most knowledgeable expert I know is my friend Pietro, who is a professor of bioinformatics. So this is why we are here. Why don't you please start by asking your most pungent question to Pietro straight away.
Okay, I think my most pungent question would be, if I wanted to enter the field of computational biology, because I find it very interesting, what would be the best course of action for me in education? So what would you recommend course-wise?
Okay, so before we were talking of bioinformatics, and now is computational biology. And maybe there is a difference that is changing in time. I would say that bioinformatics was very much rooted in developing algorithms, and so computer science at its best flavor, and statistics. Okay, that in my opinion was the two ingredients that were making the sort of technical part of bioinformatics. Nowadays, there has been a shift so that the machine learning component, given there is a lot of data in the field, there is a lot of possibility to detect patterns in a blind way, in a black box. And that has allowed a shift towards deep learning. The deep learning approaches, in general machine learning, but particularly the deep learning approaches has been very, very successful. And this has has been disfavoring a lot of the explainability, understanding the ultimate reason, but the successful has been really really fantastic, and very I think everybody has perceived that neural network could really make advancement, particularly in the clinical bioinformatics aspect and so on. So that is now what has happened to bioinformatics. I would say that computational biology is a bit more sort of has widened goals, and the goals are to do some modeling also.
Yeah.
Modeling that could range from formal approaches, differential equation, discrete systems, and so on. So I think that computational biology is something that is more general. Particularly, bioinformatics has been as focused on extracting patterns from omic data, sequence data, for instance, transcriptomics, proteomics, and so on, to or to try to infer about the fold of a protein, the 3D shape. Now is the 3D shape of chromosomes. Computational biology is in some sense has a much larger focus on the entire field of biology and also medicine, so that in some sense it can be something that you can just observe as input data, the shapes of cells or plankton or worms or ants. Okay, so computational biology is much more general, in my opinion.
Okay, so you would suggest that. So I find the machine learning approach to biology very interesting. I also find the modeling side very interesting. So would you suggest that computer science would be the wiser course for undergraduate, at least?
I think that you can see a sort of triangle, and computational biology is in the middle. From one side, I would say computer science will give you a lot. Some aspect, particularly towards technological application, also engineering could give you something. And mathematics, for mathematical biology, could give you also some other aspects, studying the property, the mathematical property of models and so on. I would say that computer science probably is the field that sits more centrally in the discipline, and you can approach things from a variety of, particularly because bioinformatics is truly a computer science discipline. The link between bioinformatics and computational biology in computer science makes even stronger this. Okay, so I would suggest that computer science is number one, and then if you have particular flavors towards studying of physical properties or mathematical properties or technological property, you may think of biophysics for physics, mathematical biology for mathematics, and bioengineering for engineering.
Okay. Thank you.
So if I may add to that, when you are working in some field that is broadly interdisciplinary, and there are different competencies, such as we've heard, biology, computing, mathematics, physics, engineering, and so on, then it will be impossible to be an expert in all of them. So you have to be an expert in something and then have some understanding of the rest. And to decide what to become an expert in, I would advise you, first of all, to decide what's the part of all these various interconnected things, what's the part that's most appealing to you? What's the part that you're willing to go full in? Because, you know, to be an expert, you have to work really hard at it, and it cannot just be a superficial interest. The other thing to consider is, besides your own preference, which is the part that it is possible to acquire by studying it on your own in your spare time without going through the rigors of a university degree on it. For example, if you were interested in, for example, I was very interested in both philosophy and mathematics when I was in high school, right? And I really love philosophy very much. And I went to my philosophy high school teacher, who was one of the greatest mentors in my life. And I said, I really like philosophy. I also like maths, and I also like engineering stuff. And I don't really know what to do at university. What should I do? And what he told me, which I'm going to repeat to you, he's dead now, unfortunately, but it's good advice, is, you know, think about the various options. If you did philosophy at university, there's no way you could ever study mathematics, engineering, and so on your own. It's just too hard. You just won't be able to do it. On the other hand, if you get a university degree in mathematics, engineering, whatever, you can still read your philosophy books in your spare time. Of course, you will not become a philosophy scholar, because that requires full-time concentration, but you can still enjoy that part on your own to a much greater extent than you could if you did the reverse. So with the necessary changes, try and figure out which ones of these things are things you can still pick up on the side, and which things you'll never be any good at unless you actually do a proper degree on it.
Okay. But would further reading in my spare time be sufficient to be able to do maybe a postgraduate in bioinformatics or computational biology? Or would I have to have some sort of degree in biology along with computer science to be able to do?
Pietro is a very interdisciplinary person, and he's one of the few people I know on Earth who has 2 PhDs. So he may advise on that specifically.
Yeah.
I think you don't need, because you are interested in something, you want to do research on something, so you accumulate everything that is needed just to do a research without collecting a lot of things that may be not interesting. So you need to have a degree and a PhD that allow you to develop methodologies, novel methodologies, and so for instance, computer science is very prestigious in Cambridge, and that is not only, but for instance, there are so many different things that in time will come. So in some sense, a degree and a PhD in computer science may allow also to develop a vision of a field and to anticipate some new aspect. For instance, with Frank, we have done a work on the security of was more a visionary work on the aspect of privacy of DNA, but that will grow in time in the future, because in some sense we may rely on DNA as our identity card or our passport. Don't know if it's good or bad, but that means that a lot of aspects that Frank has studied also in other fields may come important for that. Okay, so I think that you should be enough general in your degree and field, and that in the PhD you get more specialized, but still you want to keep at large, so that you may see through the scientific developments in other fields what could be useful for you. Okay, so don't narrow down at this stage of your education.
Okay.
I completely second and support this last sentence. Don't specialize too early. It's I think it's a flaw of the British education system that people specialize too early. At age 15, they don't even study their own language, even if it's the only one they know. I think it's disgraceful. So you should keep a broad spectrum until you figure out what to do, because you'll change your mind and so on and so on. And if you specialize before you really know what you want to do, then you'll get stuck.
Yeah. So if I had to just pick one from the two, I would pick computer science, because I feel more comfortable with, mathematics, computer science. But do you think it's that the amount you'd have to learn for a course that would cover computer science and biology, that's just too much to do in 3 years?
No, first of all, something that you really like, you will see that it comes easy to learn, okay? And so to be very motivated, it makes everything easy. On the other side, clearly, you need to structure your knowledge and in such a way that you may, if you see the biology and the computer science has a sort of trees that are bifurcating with a lot of different leaves according to the different areas and fields and so on. You don't have to follow both trees in a very exploring both trees in a very detailed way. Okay, you have just you see that some ideas are actually in many the same concept but conjugated in a different way is in different parts of computer science and also in different parts of biology. So you want really to understand the principles behind the concept and methods in order to have the vision of the field. And then some parts of a tree is something that you will explore only if you are dedicated to work on a specific subject.
Yeah.
You should also consider something else, that we are very careful about teaching you very important things in very great detail and giving you marks and all that stuff. But actually, the stuff that we teach you is not that important. Whatever it is that we teach you doesn't matter so much. When I went to university and I studied computer engineering, most of the stuff they taught me were, important foundational things, but they didn't teach me the things that I need today. For example, I'm a security expert. There's lots of stuff on the web and so on that I need to. The World Wide Web had not been invented when I went to university, right? So they couldn't teach me that.
Yeah.
Right. And now, much of the stuff I do has to be on that. So the most important thing you get at university, from a good university degree, from a top university like Cambridge, is not the content of the courses.
Yeah.
Learning how to learn new things, because throughout your professional life, for the next 40 years after you come out of university, you will have to continuously learn new things, especially if you're in a frontier field like bioinformatics, computational biology, and so on and so on. It is not possible that the things you will need when you're a professional were in the textbooks at the time you were at the universities and undergraduate. It's just not the way it works. So you have to learn how to learn new things, how to get excited about new things, how to milk textbooks for knowledge, how to then go beyond textbook into papers and so on and so on. That's the meta level stuff that you will learn at university. And to some degree, you shouldn't obsess about exactly which courses you will take, because so long as you do well on these courses and you concentrate on it and you learn how to study a subject seriously, then whatever the subject is doesn't matter. I mean, I learned so much continuous mathematics and multidimensional things and blah blah vector spaces in my undergraduate degree, which I basically never used in my professional life. And I mean, maybe the vector spaces, yes, but certainly the continuous mathematics I never used for anything. But it was very useful to do it because it gave me a structured way of, framing things in a certain way, and also how to learn layers upon layers of complex things, which I can apply to something else, even if I've forgotten most of the stuff.
Yeah. Yeah. Okay. So would you, just to broaden and explore my interests, what would you recommend? I mean, could I do a project maybe with you, Pietro, or a student over the summer? Or if not, could you recommend a project that I could maybe work on? Like maybe something to do with protein folding or modeling some genetically related system?
Well, first of all, now, so what is your status? What is your education point?
So I currently just finished my first year of A levels. So I'm going into year 13, and I'm doing maths, physics, and biology. My school doesn't offer computer science, so in my own time, I've been picking up coding, and I've been going through my brother's old computer science textbook on my own, watching your lectures, Frank. I've gotten through the whole sorting algorithms section of the algorithm course, and I've just been picking up stuff on my own computer science wise, but otherwise in biology, I've done my first year of A level.
So in some sense, you have still 1 year before you are applying this October for Entrylevel University.
Yeah.
Okay.
Yes.
So that is also. So this summer, I have already one student who is doing a project. Actually, we are discussing about reinforcement learning, so it's not already a project. So in some sense, is not easy. But I can give you some material, and
yes,
you can look at something and try to learn, and perhaps so we can do in the future.
Okay, that would be great. Thank you. So other than that, at the moment, would you just suggest I keep coding and just get more proficient with it then?
Yes, you can have a look at some good test books in bioinformatics, but also some recent reviews, review papers may give you the knowledge of what people are interested in particular, so that you can, in some sense, try to develop a knowledge in what are the hot the most interesting areas nowadays.
Yeah. Could you recommend some textbooks, or especially good reviews?
Yes, I can do.
Yes, thank you. And I was thinking over this summer, I would code a larger project, and I was hoping that could be something, maybe I program a model for something, and preferably biology related. Could you suggest something that would be a good, entry-level project that would introduce me to this?
I don't know if you have enjoyed Frank lecture. Perhaps we can study with Frank something. But I'm already following one student of your age, and there was another applying, and I say no. So I have to be careful because of my time, because we are already in the summer. It's not is something that is so it takes a bit of time, but I can discuss with Frank if
yes, I don't take people at such a young age, I'm afraid. So I wouldn't have space for that. But if you are planning on applying to computer science at Cambridge, then be aware that the field is extremely competitive. And the people that get in at Trinity, for example, are typically people who have, medals in international Olympiads in something, not necessarily in computing. They could be in physics or mathematics and stuff like that. But it is perhaps the hardest subject to get in.
Yeah.
So if you want to apply to computer science as opposed to other subjects in Cambridge, be aware that it is one of the most oversubscribed, and you will have to face very, very stiff competition. So it will take more than just a side interest in order to be taken in preference to all the others who, being geeking out on computer science since they were in the cradle. On the other hand, you may get, since you are in such an interdisciplinary field of interest, you may approach the thing from several angles. You can specialize more in something else and then come to the computing aspect at the time of your master or PhD, or you can apply to Cambridge for computer science with a plan B of doing computer science somewhere else. You have a second choice of where you do computer science, and then you come back to Cambridge after you do your degree. If you were rejected in the first instance, there's always more chances, right? But be aware that this is a very high bar of entry for someone for whom computer science is just a personal side interest.
I have done lots of the Olympiads, the maths Olympiads at least.
That's great. That's great. So that's all we want. If you've done maths Olympiads, you're in the club. We don't care that you have a particularly strong programming experience, but you have to have aptitude towards programming. You have to be the kind of ground that if we seed programming into it, it grows there. You don't have to have lots of programming already studied, right? We don't care about that. We can teach you from zero, but it has to be someone who picks it up, right? So if you've done, mathematics at Olympiads level or physics or stuff like that, then that's good enough. But you have to have some aptitude for programming. It cannot be something you just say, well, I'll risk my chance. You have to have some other indicator to yourself first and to us next that you would be good if we taught you that stuff.
Is it just the ability to problem solve? That's a lot of it, isn't it?
Yeah, the ability to think logically, the ability to concentrate at length on a hard problem, the ability to see things through, the ability to make connections on things where you don't get a suggestion that there might be connections, the ability to apply things you've done well in the past to new things that don't at first glance look similar, but actually have a deep connection. That's the kind of stuff we look for. And also specifically, a kind of undefinable quality of being able to be taught, because there are some people who are very clever, but they are so self-centered that it's only their way or no way, and it's impossible to teach them anything new. So that also doesn't work. If you have enough of an open mind and enough of a quick brain that when we give you a hint, you grab it and run with it, that's the kind of people you want, even if you can't program yet.
Okay.
What would you add to that, Pietro?
I completely agree. And in some sense, what I can say about our way of teaching is that there is not only a lot of, in my opinion, and I can put myself away, but there is a lot of teaching critical skills, but also a lot of wisdom to make the student to really have a critical understanding of a subject. And that, in my opinion, is one of the most important thing that we teach in our department, but in general in Cambridge. The other thing is that we have a good, we have a lot of experience and a lot of passion for interdisciplinary subjects. And I think that is something that it doesn't help so elsewhere at such good quality. So that, in my opinion, is something that I found extraordinary in Cambridge, and particularly in our department.
Okay.
Right, we're coming up to the end of our time. So if you have a last burning question you haven't asked, ask us now.
So if I were to commit to 4 or even 5 years of undergrad study, do you think it would be possible for me to do the computer science course, but then, because of my extended time, maybe take a few biology modules on the side so that I could expand both interests.
Yes, but just let me tell you, for instance, I'm supervising one PhD student, Emma. She's very smart, and she started medicine, then she stopped, and now she's finishing a PhD in computer science, and she's going back to medicine.
Okay.
So is really, there is plenty of opportunities, plenty of trajectories that you can follow in order. The most important thing is to be with the right persons and to approach interesting research questions when you do think.
Yeah. Okay.